Problem 6. Points A and B lie on the graph y is equal to log base 2 of x. The midpoint of a comma ab will be 6 comma 2. What is the positive difference between the x coordinates of a and b? So let's first, just draw ourselves a rough graph to see what this problem is asking for. We have a log function that looks like this. We have point A and we have a point B, where their midpoint is going to be 6 comma 2 right here. So we're trying to find the what? The positive difference between the x coordinates of a and b. So what is basically, this length right here? So to do that, what can we say? Well, a lies on the function log base 2 of x. So let's assume the x value of a is going to be a. Well, then what is the y value? Plug it into the function, which is log base 2 of a. Let's do the same for b. b will be b comma log base 2 of b, right? And what we know about 6 comma 2? That's the midpoint. So therefore, if that's the midpoint between a and b, what can we say? We can say that the midpoint formula will be a plus b divided by 2 gives 6, and that log base 2 of a plus log base 2 of b divided by 2 is equal to 2, right? That's intuition. So that means a plus b is 12, and log base 2 of a plus log base 2 of b is equal to 4. So these are our constraints. And with these constraints, what can we say? We can now say that we can simplify the second equation, because log base 2 of a plus log base 2 of b is no more than log base 2 of a times b, which is equal to 4, which means that a times b is equal to 2 to 4, which is 16. So in other words, if a plus b is equal to 12, a times b is 16. I like where this is going. We are trying to find the distance. We're trying to find a minus b. We're given a times b is 16, a plus b is 12. I love this, because if we were to do the AOPS problem books, then we know exactly how to solve it. If we want to solve a quantity like a minus b, a plus b, for that matter, we always use perfect squares. We always use a minus b squared. Because why? Because this formula gets us a squared minus 2ab plus b squared. Rearrange it. A squared plus b squared minus 2ab will give me a minus b squared. So then we know what these values are. We know a plus b, right? Or a squared plus b squared. Well, actually we don't know that, but we can find that, right? Because we can simply do a plus b squared is going to be equal to what? It's going to be equal to a squared plus 2ab plus b squared, which is equal to a squared plus b squared plus 2ab. We know what a plus b squared is, because we know what a plus b is. We know what 2ab is. We can therefore solve for a squared plus b squared, therefore solve for a minus b squared, take the square root, and get the answer. So I might be talking a bit fast here, but let's just go through this step by step. Let's first solve for a squared plus b squared from this expression right here. We know that a plus b is 12. 12 squared is 144. 144 is equal to a squared plus b squared plus 2ab. A times b is 16, so 2 times 16 is 32. Therefore, a squared plus b squared must be equal to 112. Therefore, we can use this expression to plug it into this expression to get 112 minus 2ab. ab is 16 minus 32 will give me a minus b squared, which is the same thing as 0, and that's going to be an 8. So that is equal to a minus b squared. So how do you find a minus b? We take the square root on both sides. Therefore, this will get us what? That will get us root 80. Root 80 is the same thing as 4 times 20, which is the same thing as 16 times 5, which is the same thing as 4 root 5. Therefore, your final answer would be answer choice D.